This video is going to look at using the quadratic formula to solve quadratic equations. Remember that the quadratic formula is written as negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And this is used to solve quadratic equations of the form ax squared plus bx plus c equals 0. And basically all that's happening here is you're just taking values from the equation and plugging them into the formula. The value a, which is in front of the squared term, that value gets plugged in into 2 locations. The value in front of the variable raised to the first power would be called b. That also gets plugged into 2 locations. And finally, the constant, if it's there in the equation, gets plugged into the formula in 1 spot. Okay, what's left then is just this 2, which is always part of the formula, and this 4, which is also always part of the formula. So let's see this in action. Let's start with the quadratic equation. X squared plus 9x plus 20 equals 0. And let's use the quadratic formula on this. Now we could actually solve this by factoring, but we're going to use the formula instead. And so sometimes it helps to actually write the formula out first. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then start plugging values in. Remember that a is what's in front of the x squared term, that would be the understood 1. B is what's in front of the x term, that would be 9, and c is the constant 20. So plugging all that in, we get a negative of b, which is a negative 9, and then the plus minus notation. Square root of b again, that would be b squared, that would be 9 squared, minus the value 4, always 4, times a, which in this case is 1, times c, which is 20, and all that is being divided by 2 times a, which is 2 times that 1. So that's all the values plugged in. Now, of course, we just need to clean this up. Right? So doing that, let's start with what's underneath the radical. That's the best place to work, with what's under there. So let's leave the negative 9 plus minus the square root, and then 9 squared is 81, minus, and then 4 times 1 times 20 is 80. That's all over 2 times 1, which is 2, which then, let's see, going a little bit further, gives us negative 9 plus or minus, well, 81 minus 80 is 1, so that's the square root of 1, still all over 2. And the nice thing about that is that square root of 1 is a perfect square, giving us negative 9 plus or minus square root of 1 is 1, all over 2. And it's at this point that we now need to break this up into 2 different solutions. One solution is going to be negative 9 plus 1, all over 2, using the plus. The other one is going to be negative 9 minus 1 over 2. Working each of these individually, this gives us a negative 8 over 2, which is negative 4. This gives us a negative 10 over 2, which is negative 5, meaning that the 2 solutions to the original quadratic are the values negative 4 and the values negative 5. So this one worked out fairly nice, got some really nice solutions, and could have been also solved by factoring if we wanted to. Let's try another one. Now let's work on solving the quadratic equation 6x squared minus 5x minus 2 equals 0. And let's use the same formula to solve this, keeping in mind that in this case a would be 6, b would be negative 5, and c would be negative 2. So applying the formula, and I'll just write it over here again for quick reference, negative b plus minus the square root b squared minus 4 times a times c all over 2 times a. Let's start plugging numbers in. See, we get negative of b would actually be the negative of a negative 5. That's going to turn into a positive in a minute. Plus minus the square root of b squared, which would be the negative 5 squared. And then minus 4 times a, which is 6, times c, which is a negative 2. Keep making that radical bigger. And that's all over 2 times a, or 2 times 6. So got a lot of stuff in there, but now we just start doing some cleanup. The double negative, again, right here, that just turns into a positive. So that's just going to equal 5 plus minus the square root of. The negative 5 squared is actually negative 5 times negative 5. That gives us a positive 25. But also, when it comes to the rest of this, notice I'm just multiplying these numbers here together, and this negative times this negative are actually combined to give me a positive. So negative 4 times 6 times negative 2 is actually a plus, and a plus 48. And that's all over 2 times 6, which is 12. We can still clean up more underneath that radical. Let's do that. It's going to give us 5 plus or minus the square root of 25 and 48 is 73, and that's all over 12. And then as I look at 73, the square root of 73, really can't clean that up any further. If I wanted to, I could break this up into the solutions 5 plus the square root of 73 over 12, and 5 minus the square root of 73 over 12. And since, like we said, 73 isn't a perfect square, or can't even be simplified, that we would actually stop here. We could write them as decimals, but this textbook just leaves them like it is, and we can leave it like that, like these two, as our answers, or we can even leave it just in this form, which basically is a way of describing the two solutions without actually having to write them both out. So here's a use for the quadratic formula, which we sort of had to use because this one would not have solved by factoring, and you get a little bit uglier solutions. So this one would be complete at this point. Let's look at a third one. For our third example, let's use the quadratic formula to solve the quadratic equation 4x squared equals 1 minus 8x. Now, the first thing about this particular equation, it's not in standard form. We need everything on one side set equal to 0. And so using some basic algebra, we'll rewrite that 4x squared. We'll get rid of the negative 8x on the right by adding 8x to both sides, leaves us plus 8x. We'll get rid of the 1 by subtracting it on both sides, leaving minus 1 equal to 0. And now it is in standard form, so now we can pick out the values we need. Here, 4 would be the A, 8 would be the B, and the negative 1 would be the C. And so that's what we're going to use to plug into the quadratic formula, which, again, for reference sake, we'll write off to the side. Negative B plus or minus the square root, B squared minus 4AC, all over 2 times A. So let's start plugging stuff in. The negative of B would be a negative 8, and then plus minus the square root of B squared, which would be 8 squared, minus 4 times A, which is also 4, times C, which is a negative 1, and that's all over 2 times A, which is 2 times 4. So that's everything plugged in. Doing some cleanup on this, and again, mainly we start by cleaning up underneath the radical there. We get negative 8 plus minus the square root. Well, 8 squared is 64, but we have another double negative situation here. Multiplying a negative 4 times a 4 times a negative 1 is actually going to give us positive 16, and that's all over 2 times 4, which equals 8. Cleaning that up a little bit more, we get negative 8 plus or minus 64 plus 16 is actually 80. That's the square root of 80, all over 8. And unlike the previous problem where we had 73 underneath the square root, which did not simplify, what we want to do now here is we want to leave the answer in radical form. We don't want to write decimals, but we do want to have it in its simplest form, which means we need to do a couple things. One is we need to take this square root of 80 right here and see if we can't simplify that using our properties of reducing radicals, we can think of the square root of 80, break it up as 80 is actually 16 times 5. So it would be the square root of 16 times the square root of 5, which can actually simplify to 4 times the square root of 5. So the first thing we would do is write the square root of 80 in simplest form. This now gives us negative 8 plus or minus 4 square root of 5 over 8. Okay, and then the next thing we want to do is treating this like one of those algebraic fractions. We want to see if we can't clean up this fraction by first of all factoring the top if possible. Notice on the top I've got a 8 and a 4, and I can factor a 4 out of those, which means I can rewrite the top as 4. And then in parentheses, factoring out, I get a negative 2 plus or minus the square root of 5 all over 8. And the reason for factoring that 4 out is that now we can do some cancellation, and this 4 actually cancels into the 8, leaving 1 here and a 2 there, which means my simplified version of this answer will have just a negative 2 plus or minus the square root of 5 on the top, and the bottom is just the value 2. And yes, it's still in radical form. We haven't written it as a decimal, but it now is in its simplest radical form. And if we wanted to, we could separate this into its two solutions, negative 2 plus the square root of 5 all over 2, and negative 2 minus the square root of 5 all over 2. Although it would be just as okay to leave the answer in this simplified radical form. So that's a third example of utilizing the quadratic formula to solve quadratic equations.